Good afternoon, everyone. Today we are going to discuss how to solve the transportation problem. Okay. For the first, how to solve the transportation problem, I am choosing this kind of problem. The problem is shown over here. Here we see that the three supply points are there and the four destination points are there. Okay. Where availability also shown here and demand also shown here. The problem shows that, but the problem tells that if we are going to if we are going to transport one product from supply point 1 to destination point 1, it will take cost rupees 3 per unit. Okay. Similarly, if we transport the same product from supply point 1 to destination point 2, the per unit cost will be transportation cost will be rupees 5. Okay, accordingly like this. Now we need to allocate, or we need to transport, or we need to allocate the all those products in all each and every destination in such a way that we can minimize the total transportation cost. Okay, to solve this kind of problem, initially we need to find out the initial basic feasible solution that we already discussed. After that we can go for the optimality test. Okay, so to find the initial basic feasible solution, there are three methods are available. One is northwest corner method, second one is the penalty method or Vogel's approximation method, and last one is the least cost cell method. Okay, first we are going to find, and we are going to check how to find the initial basic feasible solution using northwest corner method. Okay, in this particular method, how to solve this? Okay, so these all are the cell, we need to allocate something in this particular cells. For that purpose, first of all, these all are right now is a unallocated cell. Okay, unallocated cell. In all the whatever the unallocated cells are present, first you need to find out the cell which is in northwest corner, which is present in the northwest corner. Among the all the cells, this is the one which is northwest corner cell, which is northwest corner cell. Okay, then you need to check this particular availability in this particular supply point is 50, and the demand point means this particular cell position, we can say that this is the S1D1 cell. This is the S1D1 cell. Okay, now we need to allocate something in this S1D1 cell. For that purpose, we need to check what is the availability in S1 and what is the demand in destination 1 point. Here we see that the availability in S1 is 50 and the demand is 20. Now you need to find out the minimum one. Okay, so availability is 50 and demand is 20. So 50 and 20, the minimum one is 20. So we are going to allocate 20 here. We are going to allocate 20 here. As we allocate 20 here, that means this particular destination point demand is met, so no need to this right now this destination one not required any kind of further product. So we can say, so total demand of the destination 2 right now met, so demand at the destination 2 right now is 0. Okay, so and accordingly, as we are supplied 20 units from supply point 1, so availability at the supply point is reduced from 50 to 30. 50 to 30, 50 minus 20 is 30. So right now availability at the supply point is 30. Now as the destination 1 all the demand is made, so we can cancel this particular sales, means no need to allocate anything in the destination 1 point. Now again you have to check all the remaining unallocated cell, all the remaining unallocated cell. Right now these are the remaining unallocated cell. In the remaining unallocated cell, you need to find out which is the northwest corner cell. Okay, now right now this is the northwest corner cell. Now this is the destination point 2. Now we need to allocate something in the destination point 2. So we can allocate it from the supply point 1. Now we see that in the supply point 1 right now availability is 30, but destination 2 demand is 20. So 20 and 30 minimum is 20, so we can allocate 20 here. We can allocate 20 here, means you need to find out which is the minimum one. 20 or 30, among these 20, 30, 20 is minimum, so we allocate 20. Now destination point 2 is demand is 20, now we allocated 20, so destination point demand is met. Right now destination point demand is 0. So that's mean demand destination point 2 doesn't need any kind of product right now. So we cancel this particular two cells also. So as we already saw, right now new availability in the supply point is right now is 10. Right now is 10. Okay. Now we have these are the remaining unallocated cells are there. Again we need to find out which is the northwest corner room or northwest corner cell in this particular matrix. Here the northwest corner cell is this one. Northwest corner cell is this one. So that means we need to allocate in the S1 D3 cell, and we need to allocate something S1 D3 cell means destination 3. Right now you see that destination 3 requirement is 50 but availability from S1 is 10. So we can minimum of this 50 and 10 is minimum is 10. So we can allocate 10 here. 10 here. As we allocate 10 here, now availability at supply point 1 is 0. So that means we can't deliver from supply point 1 to any further destination. So we cancel this particular cell. And also destination 3 already 10 number of products is delivered. So demand right now destination point 3 is 40. 50 minus 10 is 40. Okay. Right now we have these are the 4 unallocated cells are there. Now we need to find out which is the northwest corner room. Okay, here the northwest corner room is this one, so that's means we need to allocate something here. The room is coordinate is S2D3. Now S2D3. Now destination 3 point requirement is 40 and availability in the supply point 2 is 75. So minimum of this 40 and 75, minimum of this is 40. Minimum of this is 40. So we allocate this. Right now destination 3 points the demand is right now is 0. So no need to destination doesn't record anything. So we cancel this particular cell. Okay. Now and again availability in the supply point 2 is reduced. Right now the availability is 35. Now the two unallocated cells are there. Find out the northwest corner. This is the northwest corner. Requirement is 60. Availability is 35. So we can distribute 35 here. So this availability is 0. Now remaining amount we can place this here. Okay. So this way we can allocate the product in each and every cells based on the northwest corner method, northwest corner rule method. Now then the total transportation cost will be right now based on this particular method is that 20 units is distributed in the destination point 1 from the supply point S1. So total cost will be 20 into 3. Again 20 is distributed in the destination point 2. So this is 20 into 5 plus 10 into 7 plus 40 into 8 plus 35 into 2 plus 35 into 2. So total cost becomes rupees 670. So that means based on the northwest corner method, this is the way we can distribute it. That based on the northwest corner rule method, where the total transportation is become 670. So this is one of our basic feasible solution to transport the products from supply point different supply point to different destination point based on this particular problem. Okay, so this is northwest corner method. This is the northwest corner method by which we can find out the initial basic feasible solution. This is the northwest corner method. Again, I am going to tell you that how to do that. Again, just repeat. Okay. So first we need to draw the matrix here. We need to draw the matrix first. Okay, where each and every cost must be given. Each and every cost is given. Okay, the costs are 3, 5, 7, 6, then 2, 5, 8, 2, 3, 6, 9, 2. Availabilities are 50, 75, 25. Demands are 20, 20, 50, 60. So this is the matrix. Okay. So northwest corner method, to solve by northwest corner method, first method, first step is to check whether the problem is balance or unbalanced. Okay. So that's mean we need to find out what is the total availability and what is the total demand. If total availability is equal to total demand, then the problem is a balanced transportation problem. Okay. So here we see that total availability and total demand is nothing but 150 and 150. So that's mean we can say this is the balanced transportation problem. Okay. So to get a initial basic feasible solution, if we apply the northwest corner method, we have to what we have to do, we have to find from the among all the unallocated cell, we have to find the northwest corner room. We need to find the northwest corner room where from we can start our allocation. Here the northwest corner room is here, this one. So availability is 50, demand is 20, minimum of these two which is the 20. So we can allocate 20 here. So we allocate 20, so that's mean demand is met. So no need further requirement. So these rows are these columns are cancelled. Again the availability is also reduced, is right now availability is 30. Okay, again all find all the unallocated cells or available rooms. These are the available rooms. From the available rooms, the northwest corner room is this one. So find the minimum one, 30 and 20. So 20 is minimum one, so we can allocate 20 here. Okay, as we allocate 20 here, requirement is 20, so further no need to allocate anything in this particular two rooms, means as because demand is met. Now the new availabilities becomes 10. Now what are the rooms available? These are the rooms available. Which one is the northwest corner? This one. Allocate minimum of 50 and 10. So this is 10. Okay, as right now availability at this particular rows is 0, so no need to allocate anything here. Now available rooms are, these are the available. Also again the demand is also reduced from 50 to 40. Now based on this similar process, you can go, we will going to allocate 40 here, we can allocate 35 here, we can allocate 35 here. Okay, so these are the allocation. Now the total cost is getting, that is the rupees 670. This is the initial basic feasible solution based on this northwest corner method.